Video is going to go over the Chapter 8 review worksheet with sequences, series, and limits. We're first going to start with arithmetic sequences series. So right off the bat, find the next four terms of the arithmetic sequence of 2, 4.5, and 7. Now this doesn't say we have to use the formula. So I'm just going to look at my difference for arithmetic is I'm adding 2.5 each time to get the next number. So when I want to find the next four terms, I'm just going to add 2.5 to 7, which gives me 9.5, add 2.5, which gives me 12, add 2.5, which gives me 14.5, and add again, and I'm going to get 17. And there's your answer. Those are the next four terms of this sequence where your difference is 2.5. Now, number 2 is a little bit different. Number 2, we are told that we have to apply the formula. The formula, remember, we'll do it over here, is a sub n equals a1 plus n minus 1, that quantity times d. So let's figure out what we're going to do. Right off the bat, I want to know what the 24th term is. That's the goal of this problem. Find the 24th term. Now, what that means is you want to find a sub 24. So we want to know what is a of n when n is 24. If I think about that, I know n is 24. I've got n. If I look at my sequence here, I can also find my difference. I'm adding 5 each time. So I know my difference is 5. So I know n, I know my difference is 5, and I know my first term. I know a sub 1 is negative 6. So really, I have everything I need to plug into this formula. So you can make a list of what's given and see what you need to do. So I want to find a sub n when a1 is negative 6. My term I'm looking for is a 24th term, so 24 minus 1. And then I'm going to multiply that by 5, my difference. So really it's negative 6 plus 23 times 5. In that case, I get negative 6 plus 115. So the 24th term is 109. And there's my answer. So this one was a straightforward order of operations problem on it. You were given information. I looked at the formula and I plugged it in. Notice again, we made a list of it as well. Let's look at number 3. Of using the formula, or formulas, it looks like, find n for the series. A1 is 12, D is 5, and your sum of the n terms is 345. So I'm going to make a list right here. I'm given information. I know one of them is my sum formula. So I'm going to write down the sum formula. S of n equals n over 2 times a1 plus a sub n. So if I look at it, I know only one piece of information here. On the right side, I know a1. On the left side, I know my sum. So if I plug in, I know 345 equals n over 2 times a1 is 12. I don't know a sub n. So I have two unknowns here. I don't know n, and I don't know a sub n. So I wonder if there's a way I can figure this out. I know there's another formula, and especially since I'm given the difference on it. So we're going to kind of look at this. There's a formula that deals with this. Our sequence formula says a sub n equals a1 plus n minus 1 times d. And if I look at it, I know my first term is 12. I still don't know n, and that's okay. So n minus 1, but I do know my difference is 5. So I can distribute and combine like terms. A sub n is 5n plus 7. And what's nice about that is I can plug it in to this formula using substitution. What's going to give me here is I have 345 equals n over 2 times 12 plus 5n plus 7. Now what I'm going to do is I'm going to take this 2 and I'm going to multiply it over here, and that is going to give me 690 equals n, and I'm going to combine like terms, 5n plus 19. So 690 equals 5n squared plus 19n. So I'm going to see it's quadratic. I'm going to set it equals 0. 0 equals 5n squared plus 19n minus 690. That is a big quadratic. So we need to figure out what multiplies, and we need to factor it through. So if you were to do the AC method here, I mean, this is going to be a huge number. I mean, you're going to have 690 times 5 to give you the AC method for the problem. So in this case, I needed to add a 19. So I'm going to say it's 5n squared. You wouldn't have one this large on the test, plus 69n minus 50n minus 690 equals 0. 69 times 50 does give me 690 times 5, and it does add to give me 19. So I'm going to factor out my n. I get 5n plus 69. And in this case, I'm going to factor out a 10 minus 10 times 5n plus 69. So the factors are n minus 10 and 5n plus 69. So n minus 10 equals 0, n is 10. If I set 5n plus 69 equal to 0, I'm going to get n equals a negative number, which doesn't work. The problem asks us to find n, and we had to go through it with this longer process. Now, when it comes to the test, I understand completely. I jumped right into what the factors are of this using your AC method. If it's on the test, it's going to be a little bit easier to see. It's not going to be, 5 times 690. You better know those factors. So there's arithmetic for us. Now we go to geometric. So for geometric, we're looking for a multiplication pattern. So we're asked to find common ratio and then look at the next 3 terms of the sequence. So answers must be written as a fraction. Common ratio, remember, could be any term divided by the previous term. So I can do A2 divided by A1. So I'm going to take 1/10 and I'm going to divide by 1/4. Now, because it's me, I like to do it by hand. When I'm dividing by a fraction, I'm going to flip it and multiply. So I get 4/10, which is 2 fifths. So there's the first part of the problem. You're asked to find the common ratio, and I know my ratio equals 2 fifths. The next part says now use that ratio to find the next 3 terms. So I have 1 over 25, and I'm going to multiply by 2 fifths. That is going to give me 2 over 125. That's the next term. So I got to find 2 more. So I'm going to take 2 over 125, and I'm going to multiply it by 2 fifths. And then it's going to give me 4 over 625. So I have 1 term, I got 2 terms afterwards, I need to do 1 more. So I have 4 over 625, and I got multiplied by 2 fifths. So that's 8 over 3,125. There's your next 3 terms. Now, the hard part for this for some people is going to be to go through and do the math. But you have to realize when you're dividing by a fraction, that's not a pre-calculus skill. You should know you're supposed to flip it and change multiplication. If you use your calculator, you can do parentheses 1/10 divided by parentheses 1/4, and then hit the math fraction button. And there's your 2 fifths. You could also do the alpha y equals and do 1/10 divided by 1/4 and just hit enter, and it'll automatically give you 2 fifths as well. So you can use your calculator to help you out for that one. By applying a formula, find the sum of the first 10 terms. So first 10 terms, so 10 is my n. I know my A1 is 5/2, that's not bad. I now want to find, it looks like my ratio. The formula is for this one, A1 times 1 minus R over 1 minus R. So I know A1, I know N, I want to find my sum, I need my ratio. Well, I could do from here to here, what do I multiply by? But for me, it's easier to see from 5 to 10, I'm multiplying by 2. So I actually have all my information I need. I have my R's too. So I'm going to write down, I'll do over here, 5 halves. So my sum equals A1. So 5 halves, parentheses, 1 minus R, so 1 minus 2, to the n power 10 over 1 minus 2. Now, personally, I could go right to my calculator for this. Now, I know the bottom is going to be -1, but I'm going to go to my calculator, and I'm going to use my alpha y equals and hit the fraction, and I'm going to type it in. I have 5 halves, parentheses, 1 minus my R, 2, to the 10th power. Now on the bottom, if you really want to write down 1 minus 2, you can. If you just want to type in -1, you can as well. And I hit enter. In this case, you get 5,115 halves. So that's my answer. My sum is 5,115 halves. Now in this case, since it's halves, it's not a bad decimal for us to use. If it was thirds, you would not use the decimal because that is a repeating decimal. You'd have to give me the exact fraction. Either one of those are acceptable. By applying a formula, find the sum of the first 8 terms of this series. So again, a little bit interesting. We want to find the sum of the first 8 terms using the formula. So n is 8. I know my A1 is 4. I guess I have to figure out what's my ratio. What am I multiplying by on here? So remember, your ratio is any term, I'll do the second term, divided by the previous. So in this case, the 4 cancel out. My ratio is square root of 2. So if I think about my formula, S equals, I know A1, I now know my ratio, I know N, I think I have everything I need. So I'm going to plug it all in. My sum is equal to 4, parentheses, 1 minus, and since it's a radical, square root of 2, n of parentheses, and n is 8. I'll do a bigger one, and on the bottom, 1 minus radical 2. So there it is. I'm just going to plug that in my calculator. So I have, again, I love alpha y equals fractions. I spent years counting my parentheses. Now I don't have to. 4 parentheses, 1 minus, and I am going to put the radical 2 in parentheses because my teachers taught me well. And there we go, and I'm going to do the 8th power on the outside. It looks just like how I wrote it down. And at the bottom, I have no idea what 1 minus square root of 2 is off the top of my head, so I'm just going to write it down, 1 minus square root of 2. So that's good. Now, it is going to give me a decimal in this case because radical 2 is an irrational number. So I'm going to get as close as I can, so I'll just round it 2 places for this. So 144.85. So my sum is approximately 144.85 for the first 8 terms. And there's your answer. Now notice in this case I accepted a decimal, and the reason why is because your ratio is an irrational number. I did not accept a decimal. Well, I would accept a decimal if it was here, but if it was thirds, your ratio is nice. I expect a nice answer. So there's geometric sequences and series for us. We're now going to do limits. And these are limits towards infinity. So we're either going to approach a number or not approach a number. And it says we're going to show work of breaking them apart for at least 2 of these problems. So we got to figure out which 2. I'll show work on the first one. Pretty straightforward and easy. Not too bad. And then we'll figure out what the other one is at the end. So showing work means we're going to split it apart. So in this case, I'm going to split, and I'm going to do the limit as n approaches infinity of 6n over n minus the limit as n approaches infinity of 3 over n. And notice in this case, the first one, the n's cancel. So really I'm asking you, what's the limit as n approaches infinity of just the number 6? and that's just 6. Minus, what's the limit as n approaches infinity of 3 over n? Now in this case, as n gets bigger, 3 over 999999999 dot 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 keeps getting bigger, bigger. This is going to be 0 because you're dividing by a really, really large number on it. So the limit there is 0. So 6 minus 0 is 6. There's your answer. That's showing all your work by breaking them apart on it. Now, how do we do it without showing the work? Because, man, that's so much faster if we recognize the patterns. Well, I can either plug in a large number and just see what happens, or I can remember in this case, I'm just going to focus on the first term. The first term at the top is 6n, and the only term at the bottom is n. And in this case, if I look at my variables, they're going to cancel, and they're going to give me 6. There it is. Done. For the next one, let's just do the shortcut for this one. The shortcut says, look at your first terms only. So n cubed is really 1 over n cubed. 2n cubed in the bottom. I'm not going to worry about the rest. I'm going to focus just on the first terms. In this case, the n cubes do cancel. And what am I left with? Just 1/2. So that's not too bad. So if I look at the ninth one, I'm going to kind of do the same thing. I'll show work for this one, but I'm just going to talk about the shortcut as well, because the shortcut's so much faster if we look at the patterns with the first. If I look at this one, I'm going to do the same thing I did above. I'm going to split it apart. So I have the limit as n approaches infinity of n cubed over 3n squared plus 1, plus the limit as n approaches infinity of 3 over n squared plus 1. So now if I take a look at this, in this case, if I focus on the first terms, I'm going to have n cubed over 3n squared. Here, when I cancel, I'm going to be left with n over 3. This one, it approaches infinity. It does not exist. It approaches infinity for that first one. The second one, if I take a look at it, it's 3 over n squared if I look at the first terms, which in this case approaches 0. Well, if the first one doesn't exist and you're adding 0 to something that doesn't exist, I imagine it still does not exist. The limit here does not exist because it's infinity. Now, the shortcut's much better. The shortcut says, look at the first terms, just n cubed and 3n squared. If I were to simplify, I would be left with n over 3. Now, if I'm plugging in infinity to n, I'm going to have a huge number on top, and it's going to approach infinity on top. Divide by 3, I'm still going to get infinity. So when the number's on top, that's when it does not exist. You have your variable divided by a number. The third one, the last one here, number 10, I got to be a little bit careful. I have to distribute out. So I have 3n minus 3n squared plus 4 minus 4n over n squared. So really I have the limit as n approaches infinity of negative 3n squared minus n plus 4 over n squared. And I just have to think about what I'm going to do. So in this case, if I look at this limit, I am going to have the first term. I'm going to have negative 3n squared over n squared. That's all I care about. I don't care about any of the other terms. And what happens? The n squareds cancel. So what am I left with? Just negative 3. And there is the limit as n approaches infinity. What we want to do is we want to make sure we understand the pattern. You can really plug in a large number. So if that's you, go for it. Plug in a large number. If it's not you, there's a pattern for it we've kind of talked about during the lesson. When you don't show work, it's a pattern of 3 cases. You're either going to have a number over your variable. In that case, your limit is 0. Because you're taking a constant and dividing by infinity. And it gets smaller and smaller and smaller. You're going to have your variables cancel like they did in a couple of cases, and you're going to be left with a number over a number. Well, in that case, that is your limit because there's no variables to plug into. The third case is what if you have the variable left on top and a constant on the bottom? Infinity divided by 2, by 3, by 4, not going to affect infinity too much. So that is the one where it does not exist. And that's where the shortcut looks like. Is I looked at my first terms, I just tried to see what happened. And that's a perfect way to do all those problems. It just asked us to show work on a few of these so we can remember how to work with breaking apart limits. But this, in my opinion, is a good way to be able to recognize it. It's very similar to end behavior with horizontal asymptotes. All right, let's look at number 11. So if I look at these, I think A and B go together. And we have C and D go together. So I want to use the graph. To the right, there it is. I want to find f of -1. So if I plug in -1 to my graph, so here's -1, I plug it in, it's going to spit out this location for me. So that looks like 1. So it goes through it, it's no open circle, it's straightforward and easy. Now, if I want to find the limit as x approaches -1, I want to go from the left side, and I'm going to see as I follow from the left and infinitely closer to that point, what is it pointing towards? And as I come from the right, and get infinitely close to that point, what is it pointing towards? And it looks like it's pointing towards 1. So we have both of those. Now in this case, they do equal each other. So we can say that this function is continuous at x equals -1. It's just asking us to find them. I'm using just the idea of what continuous means is the match. If I take a look at C and D, these two go together. So if I look at C, find f of 2. So here's 2. Now, if I look up here on the graph, that's an open circle. So that can't be the value. If I look, there's my closed circle. So that is the value. But as I go for the limit, as I come from the left side and I approach this graph, boom, 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 and get infinitely closer to x equals 2, come from the right side, approach that graph, infinitely closer to x equals 2. It looks like it's approaching 4. So in this case, they are not the same. So we say it is not continuous. It is discontinuous at x equals 2. So recognize if there's a hole, there's most likely going to be a different pattern there, which can show discontinuity. All right, we'll do these ones. Evaluate each limit. So I make a note right away. Based off of this, I see this as a rational, a polynomial or polynomial. When you want to evaluate this, you have a rational. Your job is to factor. So if I factor the top, I get a GCF of x out, x plus 3. And then the bottom, I don't have to factor, it's just x. So in this case, these x's are going to cross out. So really what I want is I want the limit as x approaches 0 of x plus 3. So factor, the next thing I did was I crossed out any common factors. And now what you do is now you plug in. Because now you removed that one that caused the problem. That x on the bottom caused a big issue. So if I plug in, I'm going to get 0 plus 3. My answer is 3. So there's the value of the limit. So I analyze first. If it's rational, I'm going to factor, cross out, and then plug in my number. So if I look at number 13, it is irrational. So I'm going to factor the top. What multiplies the 2 adds to -3, x minus 2, x minus 1. On the bottom, I have an x minus 1. Look, the x minus 1's cancel. That crosses out. That removes the problem that we have on it. And I'm left with the limit as x approaches 1 of x minus 2. Now I can plug in. 1 minus 2 is negative 1. There's your answer. And then number 14, that's another rational. So I'm not going to copy and paste. The rules are, if it's rational, factor. So what multiplies to negative 15 as a negative 2, x minus 5, x plus 3. On the bottom, there's a GCF. I could take out an x and x plus 3, and just the x plus 3 is canceled. So really, I want the limit as x approaches 3. I'm left with x minus 5 over x. This I can plug into 3 minus 5 over 3. And I get negative 2 thirds. So when it's irrational, your job is to factor, cross out, and then plug in. And so in this case, though, if I take a look, I can't factor. I mean, you might want to say, oh, it's going to be x plus 3, x minus 1. That doesn't work. X minus 3, x plus 1. That gives me a negative 3, so that doesn't work. It can't be factored in the top. Let's look at the bottom. I can't factor that. So I'm just going to leave it alone right now. In this case, when there's troubles with the factoring, let's just go, I can't factor, so I can't cross out. So let's just try plugging in and see what happens. 1 squared minus 2 times 1 plus 3. That's the top. So 1 minus 2 plus 3 is going to be 2. 3 times 1 squared minus 5, so that'd be 1 minus 5, so 3 minus 5 is negative 2. That's actually not bad. I get a nice answer, negative 1. It actually allowed me to plug in. So that means because I could actually plug in the number for it. 12, 13, 14, I had to factor and cross out because my limits, 0, 1, and 3, were part of the factors that we crossed out. So I couldn't plug them in right away. It would have been undefined. If you can plug it in and get a number, great. You don't have to factor cross out. But if you can't, you're going to have to follow that step for the rationals. All right, so that is your review worksheet. All set, all explained. Should be good for any questions you have. And this time, I see you.